Our last topic for today is what line fits our data whenever we've said, okay, so the correlation is large, it's close to 1, so there is a line that passes through our data. So what's the best line that comes as close to passing through all of our data as possible? Okay? And so that's going to be called the least squares fit or the regression line. We call it both. And so basically what we're going to do, and I'm going to walk you through kind of the result and how we get it. If y is equal to mx plus b, right, so that's our general form of a line, we want to find the m and the b which make the fit the best to our data, right? What are those m and b that fit best to whatever our data points xi and yi are, okay? And so what we're going to do, the way we're going to do this, is we're going to set up a function s of m comma b, so this is a function of these two variables, where we take the difference between yi and m times xi plus b. So if we've got a data point, x, say our data point is 1, comma 3, we're going to plug 1 into m plus b, mx plus b, so m times 1 plus b. And we want that to be as close to 3 as possible. So we're going to take the difference, we square it, and the reason we square it is just to get rid of the problem of positives and negatives canceling out. We've talked about this a few times. So we square that difference, and we want to minimize that difference, okay? So we're trying to find the minimum of this function. We want all of these numbers to be as small as possible, and so we're going to square each of them to get rid of the positive and negative problem, and then make the sum as small as possible, okay? How do we minimize a function? Well, you find the minimum of a function by taking the derivative and setting it equal to 0. Now, this is a function of two variables. I think everybody either has taken Calc 3 or is in Calc 3 right now. Maybe a few of you haven't. But just like in Calc 1, where if you want to take a derivative of a function and set it equal to 0 to find the minimum, if you have a function of more than one variable, you just take the derivative with respect to each variable and set that equal to 0. So we take the derivative of this as a function of m. We take the derivative of this as a function of b, okay? And set both of them equal to 0. So if we take the derivative with respect to m, you can see the 2 comes down to the front. The derivative of yi is 0 because it doesn't have any m's in it. The derivative of negative mxi is negative xi. The derivative of negative b is 0. And so we just get 2 times all of this in the inside times negative xi by the chain rule. Similarly, the derivative with respect to b, the 2 comes down to the front. Derivative of yi is 0. Derivative of mxi is 0. We've got a negative b, the negative sign and the b combine, negative b. And so that gives us a derivative of negative 1, which by the chain rule ends out in front again. Okay? So what we do, now that these are each equal to 0, we're going to solve for b and m. And I'm not going to go through all the details. I am going to show you. So if you take this first equation and solve for b, you get this, what I've got down here at the bottom, the sum of xi times yi. So that comes from this piece here, minus the sum of mxi squared. That comes from this times this. And then divided by the sum of xi, and that gets you b. The 2's cancel out on both sides. So you can solve for that pretty easily. You can plug that into the other equation. So if you take all of this and plug it in for this b, then you can solve for m in terms of xi and yi. It's a lot of algebra. I will, if you want to see it, it's in the textbook or any kind of source on regression. But what you end up getting is at the end, after you've set these derivatives equal to 0, you get the formulas m is equal to n times the sum of xi, yi. N here is the number of data points. So if like we have 4 data points, n is equal to 4. So n times the sum of xi, yi minus the sum of xi times the sum of yi, all divided by n times the sum of xi squared minus the sum of xi squared, quantity squared. Okay? So that's what m is equal to. That's b then is pretty easy to find. So to find b, you just take y bar, which remember was the average of all the y values, minus m times x bar. And that'll tell you what b is. So once you've got m, b is pretty easy to find. Okay? So I'll post in the Excel document with covariance and correlation. I'll also show you how to calculate these and to get m and b for that particular example. It is relatively easy to get in Excel. If you highlight a set of data points and do a scatter plot, you can get this regression equation very easily, and I'll show you how to do that as well.